Hello, teacher. Hello, students. Welcome to today's lesson on performing operations on sets. In our last lesson, we studied the union and intersection of sets. We learned that the union of two or more sets includes all elements that are in each set. The intersection of two or more sets includes only those elements that are common to both sets. Today, we will learn about the difference between two sets. Students, let us begin. The difference between two sets is called the relative complement. The relative complement of set B with respect to set A is the difference between A and B. It is denoted by A difference B, or sometimes A less B. The relative complement of set B with respect to set A is the set containing all elements in A that are not in B. In this Venn diagram, the complement of B relative to A is represented by the shaded area of A, which is not part of B. When we refer to the absolute complement of a set, we mean the set containing all elements of a universal set, U, that are not in set A. The absolute complement of A is denoted by A prime or A complement. A complement is the set containing X, where X is an element of the universal set, but not an element of A. Using a Venn diagram, we can represent A complement by the shaded region as shown here. When we draw two overlapping circles within a universal set, four regions are formed. Every element of the universal set U is in exactly one of the following regions. In the first region, the elements are in A, but not in B. This represents A less B. The second region has elements of U in B, but not in A. This represents B less A. The third region has elements that are in both A and B. This is the intersection of A and B. The fourth region has all the elements of U that are in neither A nor B. This is the complement of the union of A and B. Students, please find a partner to work with. Make 4 copies of this Venn diagram, and then shade the regions that represent each of the following operations. Try your best, and we will review the answers together when I return.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, everyone. Your diagrams should look like these. The absolute complement of the union of A and B has everything shaded outside of A and B. The union of A complement and B complement shaded everything except the elements that A and B have in common. This is also how the absolute complement of the intersection of A and B appears. And finally, A complement intersected with B complement appears the same as our first diagram. What can we conclude from this activity? The absolute complement of the union of A and B equals A complement intersected with B complement. The absolute complement of the intersection of A and B equals the union of A complement and B complement. This relationship is known as De Morgan's law. Now, let us move on to the symmetric difference between two sets. Let A and B be any two sets. The symmetric difference between A and B, denoted by A delta B, is the set containing all elements in A union B that are not in A intersection B. In other words, A delta B equals A union B without A intersection B. It is also found from the union of A without B and B without A. In this Venn diagram, the shaded dark region represents the part of A union B that is not part of A intersection B. This area is the symmetric difference. Let us try an activity, students. Please find the symmetric difference of these two sets.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. I hope you did not find this activity too difficult. First, we must find the union of A and B. This is the set containing A, B, D, E. Next, we find the intersection of A and B. This is the set containing B, D, since those are the only two elements in common. Next, we find the complement of the intersection relative to the union. This is the set containing A, E, which is equal to the symmetric difference. The union and intersection of sets also have distributive properties. This is apparent when we discuss more than two sets. For any sets A, B, and C, union is distributive over the intersection of sets. This means that the union of A with the intersection of B and C is equal to A union B intersected with A union C. Intersection is also distributive over the union of sets. This means that the intersection of A with the union of B and C is equal to the union of A intersection B and A intersection C. Today we have learned about the difference of sets. We have discussed how union and intersection are related to absolute complement as proven by De Morgan's law. We have also studied symmetric difference and the distributive properties of sets. In our next lesson, we will discuss the Cartesian product. Until then, thank you, teacher. Thank you, students.